Today we'll be learning how to multiply fractions. We'll learn how to divide fractions in a later video. We're going to start with this question. Question A. 8 over 9 times 3 over 4. When you're multiplying fractions, you actually do not need a lowest common denominator, and therefore you do not need to find the lowest common multiple. So let's make a little note here. No LCD/LCM required. This makes life a lot easier. There are actually two ways of solving this question. I'm going to show you one way right now. All you have to do is multiply the numerators, 8 times 3. And afterwards, all you have to do is multiply the denominators, 9 times 4. Now, you just have to use your multiplication tables here. 8 times 3 is 24, and 9 times 4 is actually 36. At this point, you have to ask yourself, is this fraction in its lowest terms? Is it reduced? So I'm just going to make a little note here on the side. Well, let's go ahead and find the greatest common factor, the GCF of both 24 and 36. 24 has the factors 1, 2, 3, 4, 6, 8, 12, and 24. Let's make a little bit of space here. The factors of 36 happen to be 1, 2, 3, 4, 6, 9, 12, 18, and 36. As you can see here, there are many common factors among these two sets of numbers. However, I'm looking for the greatest common factor, and the greatest common factor happens to be 12. So what I'm going to do now is I'm actually going to divide the numerator by 12, and I'm also going to divide the denominator by 12. 24 divided by 12 is 2, and 36 divided by 12 is 3. And that is our final answer, since 2 over 3 cannot be reduced any further. As I mentioned earlier, there's actually two ways of solving this question. I'm going to call this method 1. If you like this method more than the method I'm going to show you next, go ahead and use it. However, if you like method 2 more, then use that. There are different ways of coming to the same answer. So let's scroll over to the side. And again, we're going to be looking at the exact same question, which was 8 over 9 times 3 over 4. The very first step here is to do something called cross reduce. If you look at the words very carefully, it involves the word cross. We're going to look at numbers that are across from one another, so 8 and 4, and we're also going to look at the numbers 9 and 3, which are also across from one another. As you remember, we've also reduced fractions before using something called the greatest common factor, or GCF. So first off, we're going to take a look at the numbers 4 and 8. So 4 has the factors of 1, 2, and 4, whereas 8 has factors of 1, 2, 4, and 8. If you look really closely, you'll see that there is a common number, a few common numbers between these two sets of numbers, but the greatest common factor happens to be 4. We're going to use that greatest common factor of 4 to divide 8 by 4 as well as 4 by 4. However, we are going to also find the greatest common factor of 3 and 9 right now. So let's go ahead and do that. So the factors of 3 happen to be 1 and 3, while the factors of 9 happen to be 1, 3, and 9. Again, if you look very closely, the greatest common factor happens to be 3. So we're actually going to divide 9 by 3 and 3 by 3. So let's get started on that. 8 divided by 4 happens to be 2. 9 divided by 3 is 3. 3 divided by 3 is 1. And 4 divided by 4 is 1. Since this is multiplying fractions, you do not need to mess with the lowest common denominator and or lowest common multiple. So you just have to multiply the numerators and denominators. So we have 2 times 1 over 3 times 1. Let's make a little bit of space for ourselves. So 2 times 1 is just 2, and 3 times 1 is 3. As you can see, we've come to the same final answer, and again, we do not need to reduce because 2 and 3 are both prime numbers. So to recap, there's actually 2 ways of finding the same answer. You're more than welcome to use whatever method which you find easiest for yourself. In our second question, we have 1 and 2 over 3 times 1 and 1 over 4. You'll notice that these are both mixed numbers. We've seen these before in previous videos. A mixed number contains both an integer and a fraction. Now, these aren't very useful to us, so we actually want to convert these mixed numbers into improper fractions, meaning we want the numerator to be greater than the denominator. So let's do that. Over here we have 1 times 3 plus 2. The denominator stays the same. And over here we actually have 1 times 4 plus 1. And the denominator stays the same, so it remains 4. At this point, you can just use your BEDMAS. We're going to do multiplication first. So 1 times 3 is 3. The plus 2 remains the same. The denominator remains the same. Over here, we have 1 times 4, which is 4, plus 1. And then the denominator stays the same as well. So let's go ahead and add this up. 3 plus 2 is 5. 3 remains the same. 4 plus 1 is 5, and the 4 remains the same. At this point, you can ask yourself, am I able to cross-reduce? Now, just looking at these numbers, I can already tell that you cannot cross-reduce. So we are actually going to stick with method 1 for the rest of this question. So let's just go ahead and multiply the numerators. So 5 times 5. And we can go ahead and multiply the denominators. 3 times 4. So let's go ahead and simplify that. 5 times 5 is 25. And 3 times 4 is 12. At this point, you should notice that 25 over 12 is an improper fraction. However, we want to convert this back to a mixed number. So let's go ahead and do that. I'm just going to make some space, and I'm going to take 25 and I'm going to divide it by 12. So 12 goes into 25 2 times. 2 times 12 is 24. We're going to find the difference between 24 and 25, which is 1. So we have a remainder of 1. Now, this 2 becomes the integer. This 1 becomes the new numerator. And the 12 is the denominator. And that is our final answer, 2 and 1 over 12. We're going to do one more question together. We have 1 and 3 over 4 times 2 and 3 over 14. Right off the bat, you should notice that these are both mixed numbers. So we would like to convert these into improper fractions as they're easier to work with. So let's go ahead and do that. Here we have 1 times 4 plus 3 over 4, and then you have 2 times 14 plus 3 over 14. So again, we're going to use our BEDMAS. 1 times 4 is 4. 2 times 14 is 28. So let's go ahead and simplify this even further. 4 plus 3 is 7. And 28 plus 3 is 31. At this point, you need to ask yourself, can I cross reduce here to make life easier for myself? So let's go ahead and find the greatest common factor of numbers that are across from one another. But first, let's make some space for ourselves. So the first numbers we're going to look at are 7 and 14, since they are across from one another. 7 has the factors of 1 and 7. 7 is a prime number. 14 has factors of 1, 2, 7, and 14. Immediately, you can see that the greatest common factor of 7 and 14 happens to be 7. So what you're actually going to be doing is you're going to be dividing 7 by 7 and 14 by 7. Before we do that, let's take a look at the other set of numbers which are across from one another. So we're going to take a look at 4 and 31. 4 has the factors of 1, 2, and 4, while 31 has the factors of 1 and 31, making 31 a prime number. As you can see here, the greatest common factor is only 1. So I'm going to write this in, but it's kind of redundant because anything divided by 1, as you know, stays the same. So let's go ahead and simplify this. 7 divided by 7 is just 1. 4 divided by 1 is 4. It stays the same. 31 divided by 1 is the same. It stays 31. 14 divided by 7 is 2. Once we have that, let's just go ahead and multiply the numerators and multiply the denominators. And let's just make some space for ourselves. So here we have 1 times 31. Anything multiplied by 1 stays the same, so that's 31. And 4 times 2 happens to be 8. And what you'll notice is that this is actually an improper fraction because the numerator is greater than the denominator. So let's go ahead and change this back into a mixed number, which will contain an integer and a fraction. So let's make some space for ourselves. Let's go ahead and divide 31 by 8. So 8 goes into 31 3 times. 3 times 8 is 24. If you subtract 31 and 24, you're going to be left with 7. So it's going to have a remainder of 7. We're going to take that 3. That's actually going to become the integer. That 7 is going to become the new numerator. And that 8 is actually going to become the new denominator. And our final answer is 3 and 7 over 8.